Alright, looking at this next one, how many grams of O2 gas are there at STP in 6.30 times 10 to the 26 molecules? Alright, so we start out with 6.30 times 10 to the 26th molecules of O2. And we know molecules of O2 has to go on the bottom because it has to cancel with that one. And we're looking for grams of O2, so I'll put that on top. Now it's okay to talk about this relationship because you can see molecular weight in grams is equal to that many molecules. So the molecular weight is 32.00 grams, and the number of molecules that equals is 6.022 times 10 to the 23. The reason we can get away with this is because this equals 1 mole and this also equals 1 mole. So they equal each other, which means we can put one over the other like this. Now when we do this, you'll come out in your calculator to be 33,477.25, etc., etc. But you see we've only got 3 significant figures here, and we've got 4 sig figs here and 4 sig figs here. So if we're dealing with 3 sig figs, we have to find a way to convert this down to 3 significant figures. Now there's 2 ways of doing that. I can either write this as 33,500, which makes these zeros not significant because there's no decimal here, or I could say it's 3.35 times 10 to the 4th, and that would work as well. And that's going to be grams of O2, of course, right there. Alright, so that's how we would get that answer right there. On the next one, it's asking 1 molecule of MgSO4, what's its mass? So we're going to start out with 1 molecule MgSO4. And you can see that molecules of MgSO4 will go on the bottom here. And on top we're going to have grams because we want to find out the mass. So it would be grams of MgSO4. So we need a relationship now between grams of MgSO4 and molecules of MgSO4. And the relationship's up here. The molecular weight in grams is equal to that many molecules. Since we're dealing with a compound here, we can talk about molecules. Alright, so we're going to start off with, let's see, 120.38. That's the number of grams in 1 mole. And this is the number of molecules in 1 mole. So that equals 1 mole and that equals 1 mole. So it's okay to put those over each other and say they equal each other. So there's this many grams in this many molecules of MgSO4. Alright, so we go ahead and we do that. We end up with 1.999 times 10 to the negative 22 grams. Again, a very small amount because we're only dealing with the mass of 1 molecule here. Now for significant figures, the 1 doesn't matter because the 1 is an exact number. You can't have 1.5 or 1.3 molecules. The 1 is exact, meaning it doesn't count for significant figures. So what we're looking at here is we've got infinite significant figures, 5 significant figures and 4 significant figures. So that's why the answer is going to come out to be 4 significant figures as it is down here. And again, be careful to look at the magnitude and make sure that looks good to you. The important thing for both of these is to make sure that in your calculator you enter in the 6.022 times 10 to the 23 using your EE button like this, 6.022 EE23, or it could be EXP depending on your calculator. And if you do that, then you won't end up with any order of operation problems, and you should end up getting the answer that you need to. Make sure that your answer makes sense. For this one, for example, you expect a small answer. For this one, you expect an answer in the range of what we've got here. So make sure your answer makes sense, and that will be ensured by putting your exponents in your calculator in the proper way.